All right, Dr. Lane, we have what we have here is a work energy reassessment video for Drew Cavell. And this particular problem is a trailer on an incline of a certain amount with a certain velocity heading up the incline. Something falls off the trailer, moves down the ramp, and we want to try to find out the velocity, the final velocity of that particular item that falls off the trailer, using kinetic energy, potential energy, and then some rotational terms also. So I'll go ahead and read the problem. It's Nick Saban is towing a trailer full of national championship trophies up on an incline of 13 degrees above the horizontal. Even though Nicky is very graceful, as we know, and manages an impressive speed of 11 meters per second, when he reaches the mark on his journey of around 1,110 meters, one of the trophies falls off the trailer and rolls back down the incline. What we want to find out is how fast the trophy is rolling or moving when he gets to the bottom of the incline. So when he gets right about there. And what we're going to start out with is this equation. And what it's going to be is going to be kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final minus the non-conservative work that is done. So since it's basically a ball rolling down a hill, we're going to have not only a translational movement or term, but it's also going to be a rotational term. So that's why you see in kinetic energy 2, we have a 1/2 IW2, which is going to be the rotational term for the trophy rolling down the hill. One thing I did in this problem, which is something I definitely got out of your class, because it's something I've never done before, is I took the problem from its most basic form and got it down to a form which was more, or not from most basic, but I took it from this form, got it down to this form, which is a lot more basic. It's a little bit easier to work with. That way I can plug in my knowns, from up here into the equation, therefore making it a lot cleaner, a lot less work, but still getting the idea and still being able to achieve the right answer, and getting an understanding for the problem. So once we get down here, we have 1/2 velocity 1 squared plus gravity times the height, which is the 250 meters, equals 1/2 v final squared plus, that's a 1/5 right there. I know it's a little bit hard to see, but it's 1/5 v squared final. So what you're going to get is you're going to get 1/2 11 meters per second squared plus 9.8 meters per second squared, which is gravity, times the height, which is 250 meters, which is going to equal right here 1/2 times 1/5, which is 1/2 plus 1/5, which is going to come out to 0.7, because it's going to be 0.5 plus 0.2, which is going to give you 0.7 times the final velocity squared, which is going to come out to about 2480.25 meters squared per second squared over 0.7, which is going to give you a final velocity of 59 meters per second. So it's going to be moving almost 60 meters per second right here at the bottom, which is pretty quick. But yeah, that's about it. Thank you.